So hello everyone, this is lecture 14 for the atomic physics, and this is very important lecture, so you must pay attention here. So in the last lecture we were studying that what is LS and JJ coupling, and we were seeing that how can we write the spectroscopic terms for the multivalence electron system, and I told you that how you can arrange them in the increasing order of energy, and we have seen this example in the last one. So let's take one more example for this. This is P1 and P1. So what can be the S1? That is half, S2 is also half, and see these are the non-equivalent electrons because they are in the different cells. Now S is possible, means some will be 0 or 1, so this is the possible values. L1 is 1 for this, L2 is also 1. So what is the possible values of L? That is L1 plus L2 to L1 minus L2, that is 0 to 2, that is 0, 1 and 2. So now you have S 0 and 1 combination with all combined with all these L. So with S equal to 0, multiplicity will be 1 and L will be 0, 1, 2. So it will combine with S and it will give you J equal to 0. So first term will be 1 as 0. This 1 is multiplicity, that is because of S equal to 0. Similarly, you can find for S equal to 1, that is also means combined with 0, 1 and 2. So again it will give you J1, J0, 1, 2, J1, 2, 3. So these will be your terms. Now higher the value of multiplicity and lower will the energy. So they will have the lower energy as compared to this. Now in this, if you will see that which have the higher L, that will have lower energy. So this will have lower energy, and in this there are three terms. So lower the value of J, lower will the energy, because this is the less than half filled. So 3D1, 3D2, 3D3, that's how it will go, and then 3P0, 3P1, 3P2, then 3S1, and then these three terms, 1D2, 1P1, 1S0. So that's how you can arrange. So you can just solve this similarly, this D1, D1 also, it will be same. Okay, now see, you can also solve some more examples. Let us apply LS coupling scheme to obtain all the states associated with the electron configuration 1s2, 2s2, 2p5, 3p1. So what will contribute, means which will contribute in this. So this 2p5 and 3p1 will contribute, others are paired up. So see, this, if you consider this p5, then these 5 electrons will be make this very complex. So see, this 2p5 or p5 will give you the same terms as p1. Okay, so how you can see this, like you have P, in P you have 3 orbitals. So there will be means if there is only one electron, then there will be different combinations possible, that how you can fill in this all these vacancies. Similarly, if you have P5, then there will be one vacancy, and that vacancy have the same number of combinations possible as one electron can be filled in all these. Similarly, one vacancy can be filled in all these. Okay, so if you find the spectroscopic terms for the 2p1, that will be same for 2p5. So if it is given something like that, so you just find for the 2p1 and 3p1, they will give you the same terms as for the 2p5 and 3p1. Okay, so in place of this we will find for these, and we already p1 we already find it, so we know how to find the terms, and they will same for this. So that's how you can solve them. Similarly for p2, they will be same as p4, and p1 same for the p5. So you must remember this will be very easy method to solve. Okay, same spectroscopic terms you will get. So only the energy sequence will change, otherwise all terms will be same. Okay, energy sequence will change according to the J value, that if it is more than half filled, then higher J will give you lower energy, and if it is less than half filled, lower J will give you lower energy. So you have to follow the rules and you will get the terms. So terms will be same, energy order will be different here. Similarly, if you need to find this ground configuration for the scandium, is this configuration is given, we need to find the spectral terms. So only this 3D1 will contribute. So there will be only S1, that is half, and L1 is, that is 2 for D. J will be L1 plus minus S1, that will give you 3 by 2 and 5 by 2. So these will be your two terms you will get. Okay, now there is one more question. Among the term symbols given as 4s1, 3d 7 by 2, 3s1, 2d 5 by 2, which one is possible? So in these, means in these four spectroscopic terms, which is possible term, means which is defined. So let's check one by one. For 4s1, multiplicity is 4, so we know this is 2s plus 1. So from here this S will be simply 3 by 2. Now if S is 3 by 2 and L is 0, so J will be 3 by 2 plus 0 will give you 3 by 2. But see here J is given as 1, so this term is not possible because J is not matching. So only for 3D 7 by 2, M is 3, so S will be 1, and L is 4D, that is 2, so this is 2 plus 1, 3. So J can be 1, 2 and 3, but here it is given 7 by 2, so it is also not matching, so this is also not possible. For 3s1, M is given as 3, so S will be 1 again, and L is 0 for S, so J will be 1, and it is also 1 here, so it is possible. Similarly for 2d 5 by 2, M is 2, so S will be half, L is 2, so sum will give you 5 by 2, 3 by 2. These two terms you will get, and 5 by 2 is matching with this, so this term is possible. So these two are possible here. Now see, till now we are discussing all the non-equivalent systems. Now if there are equivalent electrons are there, means you have p2, means both the two electrons are in the same orbitals. Then how you can find, like if you need to find a spectroscopic terms for the p2, so both the electrons are present in the p subcell, then how you can find? Because now see what is the difference it will make now. See, if you have this these two electrons, like one is here and one is here, so this half and half will give you spin as 1. But if these two both are in here, so they can't be half and half 1. So this combination is not possible because they can't be parallel. But because of Pauli exponent principle, they must be plus and minus, so that is, they must give you 0. So some will combine with 0 s equal to 0, and some will combine with s equal to 1. So they, here you just can't do that, means all with s, means all the s terms will combine with all the l terms. There you can't follow that rule. Okay, so there very much complexity is there. That's why they developed a Beats method. So that method gives us all the possible terms only, means which is possible, only those terms. So I hope you got it, that why we can't have all the combinations possible, because you can't have s equal to 1 for this combination, because they can't be parallel in the same block. Okay, they can be parallel like here and here, but in the same knot. Again, not here, not here, or not here, like this. So their combinations are not possible. That's why there will be some spectroscopic with the s equal to 0, and some L will combine with the s equal to 0, or some L will combine with the s equal to 1. Okay, total s equal to 1. So that will be very complex to remember. So that's why we have this Beats method. So only you need to follow the method I will tell you. So if it is given p equal to 2, then there will be L1 equal to 1 and L2 equal to 1. So for both these electrons, L1 L2 will be 1 1. So for both of these, ML will be plus 1 0 1 minus 1, and for this one, ML will be plus 1 0 minus 1. So you just need to put them in this kind of matrix system. So ML2 ML1, so it is plus 1 0 1 minus 1 plus 1 0 minus 1. Add them, give you plus 2 here, 1 here, and 0 here. And now here it is 0 plus 1 1 0 0 0 0 minus 1 1 minus 1 minus 1 plus 1 0 minus 1 0 minus 1 and minus 1 minus 2. Now what you need to see here, this diagonal to diagonal, this sequence. Okay, either you can take this way or this way, it will give you same. So this one diagonal sequence means these elements are combining with the end diagonal elements. So this is one sequence, and then one is remaining is this 0. So these both diagonal sequences which are starting and ending with diagonal element, so they will follow, means for them the s will be only 0. So they will go with s equal to 0 only, and this off diagonal element which is remaining will go with s equal to 1. Okay, so you must remember this rule. Okay, so for this one you will see that it is plus 2 to minus 2, so L will be 1. So this will go with L equal to 1 will go with s equal to 0, and this s equal to 0 will go with L equal to 0. And this off diagonal element plus 1 to minus 1, for this L will be 1, and s, as I told you, s will be 1 for this. So there are these two rules you must remember. All the sequences of ML starting and ending at diagonal will go with s equal to 0. All the sequences of ML which are off diagonal will go with s equal to 1. So that's how you will get all the terms possible. So for D2, L1 means, I hope you will get for the P2. For D2 it will be L1 is 2 and L2 is 2. So ML will be plus 2 plus 1 0 minus minus 2. This is another example. Okay, so again ML will be plus 2 to minus 2. So again we will make a matrix system. So add them, so you will get something like this. So again there is this plus 4 to minus 4, this is 1, and this is diagonal to diagonal, so it will follow this, that it will go with s equal to 0 only. And again this is also diagonal to diagonal, so it will go also with s equal to 0, and this is also will go with s equal to 0. Other, this one off diagonal element and this off diagonal sequence will go with s equal to 1. So this is for the L equal to 4, this is for L equal to 2, and this is for L equal to 0. So 4 2 0 will go with s equal to 0, and similarly L equal to 3, L equal to 1 will go with s equal to 1. So these will be the possible combination. Now you just follow the same rules as we did here, so you will get all the terms. So only you need is that what will the L, what will the S. So as s plus L, that's why you will get j equal to 4, j equal to 2, j equal to 0, and here it will be 3 plus 1 4, means 2 3 4, and here 0 1 2. So that's how you will get j terms and L terms, and just follow the rules to write the energy terms. So I hope you get it, that how you can find the spectroscopic terms in the equivalent electron system. Now if you need to find the ground state, so this is a very much frequently asked question in the exams, that you need to find the ground state. So what you will do, you will first find the S max. S max is just take the sum of all the electrons spin. Find the L max, take the sum of all the ml of electron. If you get S max and L max, then if orbit is less than half filled, then J will be given as L max minus S max, and if it is more than half filled, then it will be given as L max plus S max. So just that's how you will get J, and you can write means you will have S and L. So let's take some examples. If orbit is more than half filled, then J will be L plus S max. So let's see, take an example, then you will get it very easily. This is D2, so you will write these two electrons will be filled like this. So L max is simply, L is nothing but means minus 2 minus 1 0 plus 1 plus 2. For L equal to, this is 2, so that will be minus 2 to 2. So for these two electrons you will take the sum, that is minus 2 minus 1, that will give you 3. And if you take the S, then S will be half for this, half for this, so mod will give you 1. So L max is 3, S max is 1, and this is less than half filled, so it will be L max minus S max, so J will be 2. Now you have J2 and your S is 1, so 2S plus 1 will give you your multiplicity, that is 3, and this L is 3, so it will be F. So that's how you will get your ground state, 3F2. You can take this example also, D8, so it will be like this, and this is more than half filled. So see, if you need to find the L max first, so you will just take the sum of all these. So first, this all the up spins will give you 0, then for the lower spins will be minus 2, minus 1 and 0. So it will be minus 2 minus 1 minus 3, that will give you more 3. And S max is means all these 3 will give you 0, and this is half and half will give you 1. So S max is 1, L max is 3, and J is again, if it is more than half filled, it will be sum of L max and S max, so it will be 3 plus 1 4. So this is again J is 4, and S is 1, that will give you multiplicity 3, and L is 3, so it will give you F. So this is your ground state. Means again you will have the same, you will get all the terms same for D8 and D2, but see, ground state will be different, and because of the energy sequence will be different. As I told you that you will get same terms for D2 and D8, but their energy terms will be different, and means ground state will be different. So we will take some more examples in the next lecture. So I hope you get it, that how can we find the ground state. Thank you everyone.